Now we're recording. We'll go back and I'll re-talk about A and B for a second once we're done with part C. So we want to find the total distance traveled, which is the integral of the speed or the integral of the absolute value of the velocity. Now, we don't actually need to take the absolute value of the velocity on this interval. I'm going to write it there anyway, but we wouldn't have to because what do we know about the velocity on this interval? It's always greater than or equal to 60, so it must be the velocity is always positive on that interval, so the absolute value is not really doing anything, but that's fine. That comes out to be 106.109. Everybody good with that? That is meters, right? So for the first part of part C, I'm just going to go back quickly and repeat this since I wasn't recording. We just looked for when the velocity was at least 60, so we set v sub q of t greater than or equal to 60, subtracted the 60 to look at when it was above 0, and found these intervals on our graphing calculator. For part B, we were just doing a trapezoidal sum, and since the subintervals weren't equal, it was base 1 plus base 2 divided by 2 times the length from 0 to 0.3, and then the next one, 55 and negative 29 divided by 2, length of 1.4, and so on. Came out to be 40.75. And then for part A, we talked about the mean value theorem. Because the function is continuous and differentiable, the average rate of change from 0.3 to 2.8 was 0. So the instantaneous rate of change, or the derivative of the velocity, must have been 0 somewhere on that interval. Hopefully everyone's good with that. Great. All right, part D. Now we've got all of that in there for people that have left early or didn't show up today. Part D, at time 0, particle Q is at x equals negative 90. We want to use our result from B and V sub Q from part C to approximate the distance between the particles at t equals 2.8. So we need to find the position of P at 2.8. What's the position of P at 2.8? That's our answer from part B, right? Which was 40.75. And then the position of particle Q at 2.8 ought to be its initial position that is given to us right here. At t equals 0, it's at negative 90. So it ought to be negative 90 plus the displacement from 0 to 2.8 of v sub q of t dt. Good? The integral from 0 to 2.8 of v sub q should be its displacement. Negative 90 plus that gives us the position, which came out to be 45.937653. And then you just subtracted those to find the difference. Difference equals, what is it? 5.188. Any questions on part D? Back to this one, yeah. For part C or for part D? You shouldn't have integrated on part C. Right? Just, oh yeah, you did. For part D, you should have integrated on part C. For part D? Yes. Yes, and if you didn't take into the account the initial condition, you're going to get 1 out of the 3 points for that. You get 1 for doing the integral. You get 1 for having the appropriate position of Q, and then 1 for the final answer. So this is one where you would note that even if you didn't know how to do part B, right, Tom? Right, you didn't know how to do part B, right? So you couldn't find a value for that. But you could at least still get some of the points from part D, even though you didn't know how to do part B. You wouldn't be able to get this final answer because your value would be wrong, but you'd at least be able to do this. Write some crap and then say, yeah, position is 10, and then you just use that 10 to try and come up with something for D. Yep, that'd be your best bet. Yep. Everybody good with that? Oh, look, it's children. There are children here. Hold on 1 second, everybody. in the Zoom. Okay, sorry about that. A bunch of people that just took the AP test came by and were, I don't know, praising how great a job I'd done preparing them. We'll say that that's what they were doing. Mostly it was just me belittling their college decisions, but that's fine. What were we doing? Oh, we finished this one, right? We were done with this one? So we were going to do another problem. All right, we're going to do another problem. Are y'all ready to start a new problem? I wish I'd realized we'd finished that. We did those two last time, right? We did a calculator one already. Let's do this chart. That's a non-calculator one. Does that look good to everybody? People at home, are you good with that?
Yeah.
All right. I'm going to give you 15 minutes. Ready? Go. I'm recording this time. All right. So we're going to estimate the value of v prime of 16. This is something they often ask you to do. They give you a chart. They say estimate the derivative of the values in the chart. So we'll just find the average rate of change on that interval, 240 minus 200 over 20 minus 12, because 12 to 20 is the nicest little interval surrounding 16 that we've got. That gives us 40 over 8. Should have been pretty easy there for part A. I bet you had to do that on today's AP test if you were in there taking that AP test. something similar to that. Yeah, it's 1 point. not real like exciting, but 1 point. I don't even have the scoring guidelines for this stuff, but this one's definitely 1. Okay. Part B, use the correct units and explain the meaning of the integral from 0 to 40 of the absolute value of v of t. So that's the integral of speed. Integral of speed is total distance traveled. So we would say this is total distance in meters. That she jogs in those 40 minutes. Good? Yeah? Then it says approximate the value of that using a right Riemann sum and the 4 subintervals indicated. So let's approximate that using a right Riemann sum. So we'll do this down here, part B. We should have, if we're starting on the right interval, the height of that one should be 150. And we'll multiply it by that length of 16. And then we will add to that this one. The height of this one is not negative 220, though it is positive 220, right? Because it says the absolute value of v of t. So 220 times that interval, which is 4. So be careful with that. If they have you do the absolute value, make sure you take any negatives and turn them into positives. Next one should be 240 times 8. And the last one should be 200 times 12. And what did that all come out to be? $1,600? It couldn't have been 1,600. What? Anybody got a number for that? You all did this problem. Except for Patrick. Anybody agree with 6,720?
That should be right.
Okay, people at home, did any of you get an answer for part B?
Yeah,
I did,
I don't know
but
if
I
it's
did it
right
wrong.
Okay. Somebody add this all up and tell me what you get.
I got 5,820.
How much?
5,820.
5,820.
I got 7,600.
7,600. I just heard like 4 people say that. All right, we're gonna go with that. And make sure that you didn't use the negative 220 because it says absolute value. Okay. Everybody good there? Are you guys all okay at home? Okay, are you guys all okay here in the classroom? All right, great. Thank you for responding. That was wonderful. All right. Part C. Bob rides his bicycle along a path, the same path. They give his velocity. And t is minutes and v of t is meters per minute. Find his acceleration. So that should just be b prime of 5. B prime is 3t squared minus 12t. So at 5, that should be what? What is it? 25, 70, 75 minus 60, 15? 15 meters per minute per minute. Good? Any questions on part C? dB over dt, you said? Or just d dt of this? Yeah, that's fine. Yeah, that's fine. Anybody at home have a question on that? Everybody okay with 15?
What units is that again?
Meters per minute squared.
Okay.
It's meters
thank
per
you.
minute for velocity, so then meters per minute is the acceleration. Minute squared.
Okay.
Cool. All right, part D, we want to find its average velocity from 0 to 10. So average of a function, of a continuous function, is the mean value theorem for integrals. 1 over b minus a times the integral from 0 to 10, 1 over a to b, of b of t dt. And b of t was t cubed, right? To start with, it was 2 to the 4th over 4. Then the next part was, what was the next part of it? 6t squared, so that ought to be minus 2t cubed. And then it was plus 300, so it should be plus 300t. Everybody good with that or no? And then you just plug in your 10 and your 0. When you plug in the 0, they're all going to be 0. And then, so we'll just get 1/10 of 10 to the 4th over 4 minus 2 times 10 cubed plus 300 times 10, all minus 0. And if I take a tenth of that, that becomes 10 cubed, or 1,000 over 4. That becomes 10 squared, so minus 200, and that becomes just plus 300. So we end up with 350, and this was an average of his velocity, right? So 350 meters per minute. Yeah, you don't need units unless it says indicate units of measures. Like in part B, if you didn't include the units there, you would not get points for part of it. But the rest of it, if it doesn't specifically state you need units, then it's okay if you leave them. Any questions there on that one? All right, so that was page 4, is that correct? Of this document?
I think page 5.
No. Yeah, it was. You're right. Okay. So I would like you for Thursday to do page 4. And then page, what did we just do? We just did 5? Is that what we said? So 4, and then do 6, 7, no, 6, 8, and 9. 4, 6, 8, and 9 by Thursday. 4, 6, 8, and 9 by Thursday. 4, 6, 8, and 9 by Thursday. 4, 6, 8, and 9 by Thursday.